All right, so 17.22, convex mirrors. Today we'll learn how to draw the ray diagram for convex mirrors, and I'll do a practice concave mirror for you to give you that much more experience. We'll also calculate focal length and magnification for the mirrors, same equations that we learned yesterday. So convex mirrors are very similar to concave mirrors. They use the same rules that we learned yesterday. The only difference is that it is curved the other direction. That means the center point and the focal point are on the other side of the mirror, opposite to the side of the object. So for concave mirrors that we learned yesterday, P, C, and F are over here. For today, we're going to be learning the other direction, where P is over here, but F and C are on this side instead. Same rules, we're just moving these things to the other side. Again, you guys got to practice this stuff. It's not something that's going to come easy. You got to make mistakes, and you got to fix your mistakes to learn. All right. The focal point is negative. Since it is on the back side of the mirror, it is going to be negative. That is the big difference. So I'm going to briefly show you what happens with these convex mirrors, and then we're going to do a practice one. So don't write this down until we do the practice. This is your main setup. We have our object on the left side of the mirror. The mirror is curved away, so on the back we have the focal point and the center point on the right side. So when we do the ray diagrams, same rules apply as yesterday. Parallel, and then through F. Dotted on the right, solid on the left. And then through C, no bouncing. And then this is the one that people get tricked. From the top of the object through F, but stop when you hit the mirror. So you see how it's headed towards F, but we can't finish the line because now we've got a mirror in the way. It's going to bounce parallel. So parallel through F, through C, through F, and then parallel. And you end up with your object in this location. This is a fairly difficult one. You notice even on my PowerPoint up here, it's not perfectly converging. It's pretty close though. Okay, so we're going to do a practice. You guys ready for the practice? Make sure you have your ruler. Our practice today, we're going to draw a ray diagram for a convex mirror, so negative focal length. The focal length is going to be 2 centimeters with the object 3 centimeters away from the mirror and 1.5 centimeters tall. So let's start with our principal axis. And for those of you that weren't here yesterday or were not paying attention yesterday, you're going to need to draw a line across the width of your paper with about 3 lines above and below it. 3 notebook lines. And right in the center, you're going to draw the mirror axis, which will be span the 3 above and 3 below notebook paper lines. Just an idea. It doesn't have to be like that exactly, but it should help. Did you bring me a donut?
You like strawberry?
No. You have homework? All right, we're talking about a convex mirror. So we're going to take just a representation. Remember that this mirror representation is not really there. You're not going to use it for anything. When I say bounce off the mirror, I mean bounce off the mirror axis. This just reminds us that the mirror is curved this direction, and the little dashed lines mean that that's the back of the mirror. All right, from the problem, we have a focal length of 2 centimeters, but it's a convex mirror, so that's -2. The object, which is P, is 3 centimeters in front of the mirror and has a height of 1.5 centimeters. All right, remember that 2F equals C. So what's C? Close. -4. There we go. All right. Now we have enough information to start our ray diagram.
Does it say F is -2?
Yes. And that's because it's a convex mirror. All right, remember, measure from the mirror axis only. Do not measure from the blue mirror line. That doesn't count. That's just a reminder that F and C are on this side. So we're going to find F first. F is -2 from the mirror axis. We're going to put in -2, which is here, and -4, which is here. Now I'm going to just write little distances down here. You don't need to do that. This is just for people that get lost. And then we're going to draw P in. P is always on the left, 3 centimeters. This is P. Now you're using a scale of 1 to 1. I'm using a scale of 10 to 1. All right, P is 1.5 centimeters tall. So at P, we're going to put 1.5. All right, anyone still need time to catch up? Anybody have questions about the setup here? Or why we put something somewhere? Okay, now we're going to draw the rules here. Remember your rules. The first one is parallel and then through F. So from the top of the object, the very tip top of this arrow, we're going to draw parallel until we reach the mirror axis.
So you know the little mirror that you drew?
Mm-hmm.
So even if it touches that, it's okay?
Yeah, you're going to pretend like the blue part doesn't even exist.
Okay. That's just for us.
It's just to remind you that it's see going that bad. All right. Yeah, I can write that on the board. This is 1.5 centimeters tall. And I have another idea. I think I'm going to draw it like this and then draw over it with the fancy thing. All right, then it's going to go through F. So right where you hit the mirror, line it up with F. Solid on the left, dotted on the right.
Are all going like that?
They're all going to be dotted on the right. The dotted part means virtual. That work better? Oh, much better. Okay, what's the next rule? Anybody remember?
Is it the opposite or something?
It's through C. So now we're going to line up the top of the object with C. So the top of the object, now C is all the way on the other side, so we have quite a distance here to go. So draw till you hit the mirror, and then after you hit the mirror axis here, you can go dotted. That is not lining up through C here. All right, now what is the third rule, the last rule?
Through F.
F and parallel. So F and then parallel. So we're going to line up the top of the object with F. Remember, this is the one that's a little tricky because you have to line it up, but you're not going to draw all the way to it. You're going to stop when you hit the mirror. So, top of the object through F, stop when you hit the mirror. Once you hit the mirror, you're going to bounce parallel. You should get a pretty good convergent point right about there. All right, so our image is going to be right here where they all converge. It's going to be upright, which is different than what we had yesterday. And this is Q. All right, if you need my help, you want me to look at it, let me know when I walk around.
Yeah.
Is the distance from your mirror axis? Okay, excellent. Now we got to do some measurements. Let's measure this thing. All right. We want to measure the distance of Q from the mirror axis to Q. I get 1.2. I don't know what you guys get, but I get 1.2. So my Q is negative 1.2. This is behind the mirror.
I got
1.3. Okay.
Wait.
Write down what you get. Now remember, I'm doing this on the whiteboard, so gravity's working against me. It's very slippery. I'm using a meter stick, and I'm using a really big fat expo pen. So my numbers are not going to be as good as your numbers. So use your numbers. All right, then we're going to take the height of this thing. My height here is 0.6 and a half, 0.6, 0.7. That's like 0.7. So this was 1.2, and mine's 0.7. Not super great, but it'll work. So my height of, that's my image here. Not HO, it's HI. I got 0.7. So write down whatever you get for your height. Now we're going to do the math. So double check and make sure we did all this stuff right. Use our focal length equation. 1 over our focal length, where focal length is -2. Our P, make sure you're giving given values here, plus 1 over Q. So 1 over -2 minus 1 over 3 equals I have a ghost on my computer. Weird. Okay. Just gonna let it sit there. All right, if I put this in my calculator, because fractions are icky, right? Shouldn't be too hard, but, you know, we don't want to mess up. I get -0.83. If you get stuck here, do not leave it. It's easy to solve. Flip-flop the bottom and the top. Q is equal to 1 over -0.83. Q gives me -1.2. Oh, look at that. Not bad. Not bad for a whiteboard. Look. Sure. Mariah, you get checked out. All right, and last little bit here, we're going to do magnification. Double check, make sure our magnification's okay. There's 2 equations for magnification, high over ho, like you're a dwarf, and -Q over P. So HI is 0.7, HO is 1.5. And that gives me 0.47. Magnification here, -Q is going to be, and I want to use my calculated value. Actually, it doesn't really matter since they're the same value, but you should be using the calculated value to check. since this one's measured, you want all this stuff to be given or calculated. All right, and then P was 3. And that gives me 0.4. So 0.47 and 0.4, pretty good. This one matches. So my ray diagram is probably pretty close to where it's supposed to be. Again, remember the ray diagrams are with 10 points, but the calculations will only be worth 1. So you want to use your calculations to make sure your ray diagrams are pretty close. And I'll be looking at your pictures just like I'm looking at your pictures now. Even if your numbers are off, your picture still looks the same as mine. Yes?
Is 0.36 and 0.53 a big difference?
Not really. Should be fine.
What would you consider a big difference?
If I was getting something in the 1 range,
So like if it was like 0.53 and like 1.1.
yeah, then I'd be a little concerned.
Okay.
All right, any questions about this? Does anyone want to take pictures of this before I erase it? Okay. Your homework is going to be 17 through 24. Since we have a little over 15 minutes left, I would like to do another ray diagram for you, but it doesn't really matter where you move P in front of this convex mirror. You're always going to get a smaller image. It's just going to be, either a little bigger or a little smaller, and it'll change. So it's only going to really shift from here to here. So I want to do a ray diagram from concave mirror, the one that we did yesterday, that is different than the one that you've drawn last night. Last night you pretty much just kept drawing the ray diagram over and over again with a little bit of shift. I want to show you one that kind of looks like this, but with the mirror curved the other way. Does that sound good? Mm-hmm. Okay. So I'm going to erase this, and then we'll do one more. Okay, let's make up a nice one. Now remember, we want the numbers to be kind of low because we want it to fit on your paper. So we have to keep things below like 5 centimeters. We want to do a concave mirror. And what do you want the focal length to be? 2? Well, we just did one with 2. Too big. 4. Focal length of 4. No, because then my center is going to be at 8, and that's too big.
3.2.
3? I don't want to do
3.
3. We'll do 3. 3 is fine. Okay, it's concave, so it's going to be positive 3. Well, I want my image to be somewhere between the focal length and the mirror. So pick a P that is less than 3. 2 it is. All right. How tall do we want our object to be? 3? No, that's kind of big for an object.
2.
How about 1? That works. 1. Okay. Now, remember that 2F equals C, so what's C?
4.
6. There we go. All right. So let's draw our principal axis. And our mirror axis, you can put your mirror axis pretty much right in the center of the page. All right, then we're going to draw the mirror. Now, it's a concave mirror. Remember this mirror that I'm drawing, I'm going to draw it in blue. You can ignore it for the most part. It's just a reminder to say, hey, it's curved that way. Don't forget that your F and your C should be left because it's curved that way. We're going to measure out our F and our C. Our F is 3 centimeters. And our 3 is at 6 centimeters. And our P is at 2 centimeters. It also says that our P is 1 centimeter tall. What are you confused about?
I thought that the height goes at the last one. Because you have to go through F and C.
Yep, you just go backwards. Which is why I wanted to do this one for you, because it's different than what you did last night. Okay. Anyone have any questions on the setup here? Are you okay? Do we want me to double check and make sure you set it up right? Should look like fun. All right, let's do the rays. Remember the rules. The first one, paralleling through F. So from the top of the object, draw parallel till you hit the mirror. And when you hit the mirror, you're going to put it through F. It doesn't matter where F is located. What's the second rule? Through C. So line up the top of the object with C. Doesn't matter where C happens to be located. This time it just happens to be behind it. Let's pick some bad numbers. Oh, a little bit more. There we go. Okay. So you're looking for that place to cross. So this one I had to like really extend it super duper far so I could get these two lines to cross. And sometimes that just happens. It's good that we did this. Alright, so this one's through C. And just keep extending it until they cross. So we're getting it way over there. Way over there. Alright. What's the last rule? F then parallel. So we're going to line up the top of the object with F. Stop when we hit the mirror. Now my mirror is not long enough, so I need to extend my mirror a little bit. That's why the curve doesn't matter. It's the mirror axis that's important. Once you've hit the mirror, then you're going to go parallel. First. All right, so my crossing is a little off. That's okay. It's good that we're doing this one because you're going to get a couple that are kind of messed up like this. And mine's probably especially messed up since I'm doing it on the whiteboard. Yours might converge a little bit better, but you know, these things happen. You see this triangle right here? That's your converging point. So when you do get these, like, you know, it's just a matter of if you're off by a little tiny bit back here of an angle, when they go so far away, that little tiny angle just spreads them out and they start to diverge. So this little triangle is kind of what we're looking for. The best way to do is just kind of pick the middle. So let's say here, and then we'll just call that's where our image is. That's cute. It's not perfect, it's not pretty, but it's close enough. So let's do some measurements and we'll check our math and make sure we didn't make a big mistake. Sometimes that happens. So when I measure here, I get 5.5. And it's behind the mirror, so it's negative. So I just measured that and that's what I got. My height is I get 2.9 for my height.
Miss Phil,
Yeah.
I have a random question. So you know how you said yesterday how if it goes down, then it's negative?
Uh-huh.
So what if it's over there and it's going down?
It won't be.
Oh, it won't.
Yeah, not for mirrors, it won't be. Okay, so let's do the math. Let's make sure that we didn't make any mistakes. I'm a little concerned that we might have made a mistake because my area of, convergence is so big. It's possible we didn't. Let's just take a look. We got 1 over F equals 1 over P plus 1 over Q using measured value or calculated values only given. 1 over 3 equals 1 over 2 plus 1 over Q. 1 over 3 minus 1 over 2, 1 over Q. 1 over 3 minus 1 over 2 gives me negative 0.16. 1 over Q, flip-flop. Q is going to equal 6. Well, that's not bad. 5.5 and 6, that's not too bad. I will call that okay. Not great, but it's okay. Close enough. All right, let's look at our magnification to make sure our height is correct. This one could be off quite a bit because it could be anywhere from here to here. That's like 2-3 centimeters here. Well, 0.2 for you guys. All right, for magnitude, high over ho, HI is negative, or it's positive, equals 2.9 over HO, which is 1, so it's just 2.9. And magnification is also equal to negative Q over P. Let's double check that using, since this is a measured value, Let's use the calculated value here, or the ones that are given, so that we can have something to compare it to. So negative q would be negative 6 over p, which is 2, giving us 3. So 2.9 and 3, it's not off too much. It's not bad. So I would call that okay as well. So even though we ended up with this big convergent area that's not quite converging, it's still good enough. All right. Any questions on this? No? You guys are good? You want me to come around and look at it? Let me know what you do. Here. Yeah. Did you measure from here? Mm-hmm. It looks good. It would pass. I'd give you the win points for it. Let's know. I mean, your key is a little short. Okay. But you still get one. It was like I took a picture. Questions? Ask me questions back around. No. Oh, well, how much down? What you doing, Dad? I know exactly. Where did I get the negative 6? 1/3 minus 1/2? Put it in my calculator. Oh, no, if it's not right, my calculator is sliding. There's no way. Making my moments part of Any other questions? Can you look at it? Mess up? Well, messing up is part of the learning process. Okay, mess up.
That would be easy.
Two fingers? My fingers don't even start that part.
All right, your homework, 17 through 24. Got all weekend to work on this stuff. If you get stuck, go on YouTube. If you think you're going to get stuck, take a picture of the homework before you leave.